Manual calculation using trapezoidal. This is the step of trapezoidal calculation. The first step is choose n and calculate the width using the formula h equal to b minus a over n. The second step is enter a column with s values and another column with fx values. The third step is fill the table, and for the fourth step is generate x values plugged into the function. For example, h over 2 multiply with fx0 plus 2fx1 plus 2fx2 plus 2fx3 plus fx4. As you can see that the pattern for this function is 1, 2, 2, 2, 1. This is the example of the calculation using the trapezoidal. Derive using the input, the function is fx equal to 4 over 1 plus x squared, which is given in the equation. The limits are a equal to 0 and b equal to 1. The number of n chosen is 4, and then we use again the formula h equal to b minus a over n, and we got the value 0.25. This is the table that I had mentioned before, which is contain x and fx. As you can see, the value of x started from x0 until x4 because the number of n is equal to 4. And then generate x values plugged into the function. And the answer for n equal to 4 is 3.13117647058882, and the answer for 5 decimal places is 3.13118. This is the table for n value and the answer for 5 decimal places and 15 decimal places, and also the value of 5. If the answer is calculated manually using 5 decimal places, when comparing with 5, the real value of n with 0% error is n equal to 100,000. Therefore, the answer taken for manual calculation is only 5 decimal places as approved by the lecturer.
Manual calculation using Simpson. Steps of Simpson calculation. The first step is choose n and calculate the width using formula h equal to b minus a over n. Second step, enter a column with x values and another column with fx values. Third step, fill the table. And the last step, generate x values plugged into function. For example, h over 3 times by fxo plus 4fx1 plus 2fx2 plus 4fx3 plus fx4. As you can see, the pattern is 1, 4, 2, 4, 1. This is an example of calculation. We need to derive using input which is given in the question, which is fx equal to 4 over 1 plus x squared, and the limits are a equal to 0 and b equal to 1. In this case, we choose n equal to 4. So, we use the previous formula, which is h equal to b minus a over n, which is 0.25. As you can see in the table, there are two columns with x and fx values ranging from x0 to x4. We need to generate the x values plugged into function, and the answer is 3.14156862741. The answer in 5 decimal places is 3.14157. Table shows the n values, answer of the manual calculation, answer to 5 decimal places, and the pi value. If the real answer is calculated manually until 15 decimal places, when comparing with pi, the real value of n with 0% error is equal to 200. Therefore, the answer taken for manual calculation is only 5 decimal places as approved by the lecturer. Numerical solution using MATLAB for trapezoidal rules. In MATLAB, we need to use coding. So, to find the solution for the composite trapezoidal rules, we need to use the specific function that have been programmed in the MATLAB library itself. Therefore, the function is function trapeze that contains a, b, and n, and approximates the integral of a function fx in the interval a and b by the composite trapezoidal rules. N is also the number that been inserted by the user for this question and also the number of sub-intervals. And the user also need to specify the function fx at the bottom. And the calculation for hash in this MATLAB also the same as the manual calculation. For MATLAB coding, for loop also required to use, as the for loop is based on the n that been inserted by the user. For integral, the answer will be based on the function trapeze itself. And then also the changes need to be changed according to the specific problem that we got in our PBLMath that need to be adjusted before proceeding to the command line. That is function y. Function y needs to be changed according to our question. And also, format long is used in this coding as we wanted to show the longest value answer that nearest to the 15 decimal places. As our question required us to put the 5, 10, and 15 decimal places for the pi answer that nearest to pi, therefore fprintf is being used. And we also use the percent 0.15f to show the 15 decimal places. Whereas for the percent 0.5 is for the 5 decimal places and percent 0.10f is for the 10 decimal places. This is important as we wanted to show how the different answer for the decimal places will going to be shown by the MATLAB. Therefore, as we got for the function trapeze is important for this composite trapezoidal rules.
The calculation for Simpson's composite rule by using MATLAB. We use MATLAB because we want to know whether our manual calculation given a right answer or wrong. When we write MATLAB, of course, we will write the coding. At first, in the coding, we need to declare the function of Simpsons and write the value of a, b, and n. A, b is the limit of the function, while n is the subinterval. Value of a and b is given in the equation, but not for n. So, we need to find the value of n until we get the answer for the equation in pi, which is 3.14159. For the calculation, we also need to find h in order to get the answer. H is found by minus the value of lower limit with the upper limit and divide it by value of n. The value of upper limit is 0 and lower limit is 1. After we got the value of h, we can get the answer. But in MATLAB, we use loop. And in the loop, we need to enter the value of a, b, and n. After we enter the value, the coding will run in the loop. After it run the loop, it will go to the final step, which is display the answer by the given equation. We also use fprintf because we want to display the answer in certain decimal places. As for now, we display the answer in 15 decimal places. So, we need to change the percent of 0.15. If we want to display it in 10 decimal places, we change it to percent of 0.10. If 5 decimal places, percent 0.05. But don't forget, we need to write the function of the equation at the bottom of the coding. As you can see, we write function of y equal to 4 divided by 1 plus x power of 2. We also write as CLC because we want to clear all the calculation and we present only the answer. So, as the conclusion, when we try by error to find the answer of n, which is given the value of pi, we use the value of n 200.
Conclusion of trapezoidal rule. By using manual calculation of trapezoidal rule, we can obtain the closest function value to pi in 5 decimal points when n is equal to 12. The function value that we obtain is 3.140435246849. In 5 decimal point, the answer will become 3.14044. As this value is the closest to value of pi in 5 decimal point, it shows 0% of error. In MATLAB calculation, when the code is set to calculate 5 decimal point trapezoidal function value, the value of n is equal to 999,998 is the largest value of pi in 5 decimal point that's similar to trapezoidal function value, which is 3.14159. When the code is set to calculate 10 decimal point of trapezoidal function value, the value of n is also equal to 999,998. And this can obtain the trapezoidal value that's same with 10 decimal point value of pi, which is 3.415926536. Then the code is set to calculate 15 decimal point of trapezoidal function value. The value of n is equal to 100,002, shows the value that almost similar to pi, which is 3.141592653589793. As all the trapezoidal function value is almost similar to pi in 5 decimal places, 10 decimal point, and 15 decimal point, it shows 0% error in each of them.
Conclusion: Simpson rule. Simpson rule. The calculation of Simpson rule by calculate manually when n equal to 12. The answer is 3.1415926403054. The answer in 5 decimal place is 3.14159. D is the closest to the value of pi in 5 decimal places, so the error is 0%. MATLAB calculation for 5 decimal point is n equal to 198. The value is 3.14159. The error is 0%. Then the 10 decimal point is n equal to 200. The value is 3.14159265536. The error is equal to 0%. Lastly, for 15 decimal point is n equal to 200. The value is 3.141592653589793. The error is also 0%. That's all. Thank you.